Hi there, geometry students. It's Mr. Pouts with a lesson video for section 4.2. So section 2 and chapter 4. And remember, chapter 4 is all about congruence in triangles. So we've learned about just figuring out if we can find all sides and angles, all the corresponding parts to be congruent. That'll show that two triangles are congruent. Today we're going to focus on this goal, which will make life easier, and we're going to find more ways to prove two triangles congruent. The goal is I can prove two triangles congruent using the SSS and SAS postulate. Now, SSS stands for side, 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 and SAS stands for side, angle, side. So we'll learn about what those are, and we'll use those in a couple examples, and we'll even use them in a couple of proofs. All right, so make sure that goal is written down. If you're wondering what the picture, I just thought it was a cute picture of a baby. So that's why it's there. Anyway, here's our key concept. And if you read it through, it says you can prove that two triangles are congruent without having to show that all their corresponding parts are congruent. So we're going to take a look at two postulates, like I said. They'll help us prove two triangles are congruent quicker than finding all congruent corresponding parts. So the first one is the side, side, side postulate. And I know it's a postulate, but I would put it on your theorem sheet. It says if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So you don't have to worry about angles at all. If the three sides of two triangles are congruent, then the triangles are congruent. It just so happens that then the angles are also congruent. So side, side, side postulate, if you want to look at it in more detail, if you have two triangles, we have triangle ABD and triangle BCD. Actually, it would be ABD and CDB. So it should be in the same order, the same order as the first one. We have that all three sides are congruent, and only two of them are labeled. But then the hypotenuse of both of them are congruent because they're the same side, and that's that reflexive property that we're going to be using a lot more with these triangles. So if that is true, then triangle triangle ABD is congruent to triangle. It would be CDB because angle A goes with angle C, angle B goes with angle D, and angle D goes with angle B. If you're looking at the two different triangles. All right, and the other way that we have is the side angle side postulate. This is postulate 4.2. It says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So a little bit better look here. It says if we have a picture like this where we have two corresponding sides are congruent, AB is congruent to XY, CB is congruent to ZY, and the included angle, meaning the angle that's between those two sides, then triangle ABC is congruent to triangle XYZ. So what we're going to try and do here with some of our examples and some of our proofs is we're going to try and either prove that there's a side angle side congruent or side 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 congruent to prove that the triangles are congruent. Those are our two modes so far to proving that two triangles are congruent. So I have two examples. First one, it says, what other information do you need to prove, in the picture on the right, the triangle TRF is congruent to triangle DFR by the side, side, side postulate. Sorry, side angle side. So it looks like we have a pair of congruent angles there. Looks like we also have a pair of congruent sides there because that is the reflexive property. They're the same, so they're congruent to each other. To prove that we have side angle side, if I'm looking at this triangle R, DFR here, and I'll use a different color to show it, DFR. If I want to have two sides and an included angle, the other side would have to be right here. And for the other triangle, the other side would have to be right here. So we would need to have segment RT congruent to segment FD. And your explanation could simply be because that's the only side that could make it so that you had side, angle, side, with the angle included between those two sides. Right? So if we can prove those are congruent, then we can prove the triangles are congruent. Number 2 here, it says, would you use side, 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 or side, angle, side to prove the triangle is congruent in the examples below? If there's not enough information to prove the triangles are congruent by either of those postulates, just write that there's not enough information and explain your answer. So I'll do the first two with you. You can figure out the last one on your own. So A, we have side here. We have this side here if we need to use it, and then we have an angle. Same thing over on the other one. We have a side and angle. Looks like we would have ASS or SSA. Don't ever use ASS. It spells an naughty word, and it's also a good reminder that that's not illegal. So don't even try it. There is no ASS postulate. This one, there would be not enough information then. We don't have an included angle between two sides that are congruent. We also don't have all three sides congruent, or not enough information to show that we can use either of those. All right. The second one, we have two pairs of sides congruent there. We also have this third one because it's reflexive. So we do have side, side, side. Okay, why don't you try C on your own and give it a good, well, be able to explain yourself if asked to. All right, so hopefully you got that you do have a side, or two sides, two angles that are congruent. We also have vertical angles. So with that, we do have side, angle, side. That is an included angle. All right, so that's using the side, 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 and side, angle, side postulates. Now let's do a couple proofs. Now this first one that says, complete the proof using a flow proof. I have not taught you how to use a flow proof yet. Maybe I did. If not, I'm not going to expect you to use a flow proof. It's the least common way of doing proofs. It's a more visual way, though, so you might be interested in it. I'll show you kind of an example of how they look. This is one that I found that was just about bacon. Should I eat that bacon? And it's a flow chart or a flow proof. The idea behind a flow proof is that you start with, there could be more than one thing, but the first thing or two would be given and picture stuff. Stuff from anything extra from the picture. And then from there, you just give things that you know about them. So if you have that, you're given that two lines are parallel, and you can show then that this angle is congruent to this angle, that angle, by whatever reasoning there are. So you have to put the reasoning in parentheses. But this flow proof is kind of interesting how it goes from, should I eat that bacon? It says, do you want to feel like angels are frolicking on your taste buds? You could say yes, no, yes, but I'm afraid they'll kill me. If you said yes, then eat it. If you said no, then you said you've clearly never tasted bacon, so then you should eat it. So these are all the things that build off of different things. You notice in proofs, things build off of each other. This other one, it says yes, where it said, I'm afraid it could kill me. Are you a coward? I'm not, or yes, I am. If you say I'm not a coward, eat it. If you say yes, I am a coward, bacon will turn you into a true warrior. So that's what all the different ways they come up with this final conclusion here, and it's kind of an example of a flow proof. The flow proofs would look a little bit different because you're proving things. So if you want more information on that, don't hesitate to ask. For this one, I'm just gonna. Well, I can show you a flow proof. I'll show you a flow proof. See if I haven't done this one in a flow proof yet, but why not? So we'll make our first parts here. We have segment PO is congruent to segment SO. That's given. All right, another piece of information we have is that O is the midpoint of NT. That also is given. Then from the picture, see if there's anything else we can use from the picture. Well, we know that this angle is congruent to this angle, so angle, we'll say PON, is congruent to angle, that'd be SOT. Those are vertical angles from the picture. So these are all things that kind of go together. Now let's see what we can build from those. If PO is congruent to SO, well, I don't know if there's anything else we can say from that one. If O is a midpoint of NT, midpoint, meaning that cuts it in half. Oh, so we could say that from that, these two segments would be congruent. So we'd have segment NO congruent to segment TO. That would be our definition of midpoint. Keep the box around that. Got some flow going here. Oh, get this. We already have enough information. I'm going to combine those three pieces to draw our conclusion that triangle NOP and triangle TOS are congruent. Because we have a side angle side. The angle is included because of the side angle side postulate. And then we give ourselves a smiley face because we proved it. Now if you look at it, that's a flow proof. You just start listing what you have right away, and you branch off of there to see if there's anything else. Like the only thing that we could branch off of was the midpoint one, and say some things about that. And then we have enough information with that picture to combine those three pieces to prove that those triangles are congruent. So it's a very visual way of doing a proof. It is optional if you like to do this proofs this way. It's not the most common way to do it, and sometimes it takes more space than others just because of the flow. But again, it's more visual. It's a neat way to do a proof. So that would be that proof, and I'll do the last proof with you, just the regular T-chart way. This one says complete the following two-column proof. So right away we can just say that we have that segment FH is perpendicular to segment GI, and segment HI, or HI, is congruent to segment HG. So those are listed there. HG is congruent to HI. Those are labeled. And since that's perpendicular, we have the two right angles there. All right, that is given. Oops. Okay. Now this is going to be a short one too, I think. We technically did not state it yet, but we'll say that angle GHF is congruent. Well, all right. Angle GHF and angle IHF are perpendicular, are right angles. Not sure what's happening here. Why are they right angles? Well, because the perpendicular lines form right angles. I guess that's the definition of perpendicular lines. From there, then we can say that angle GHF is congruent to angle IHF, just because right angles are congruent. I think that's a theorem. I don't remember or postulate if we have it. I think it is, but right angles are congruent. So we have that those are congruent. We also have that one set of lines. Oh, we also have lines that are the same here. So FH congruent to FH. That is the reflexive property. I apologize for my writing. I'm all over the place here. That is the reflexive property of congruence. So then we have enough information here. We have a side, an angle, an included angle, and another side. So we can say that triangle FHI is congruent to triangle FHG because of the side angle side postulate. Yay! We proved it. Okay, these proofs some of them are longer than these, but these are kind of what you're doing is looking for a way to prove that they're congruent. And so far we only have those two ways, the side 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 and the side angle side. We're going to add to that. We're going to add some more ways to prove triangles are congruent. But for right now, that's kind of what we're looking at. I hope you got something out of this section of proving triangles congruent. And make sure you self-assess yourself now on this goal. Don't forget to self-assess. And otherwise, I'll see you next time.